Hi, it's been some time since I created a video, so I figured I should do one. And interestingly, there was a scenario that was being discussed a few days back, which I thought would be a good topic to discuss. Essentially, what was happening was a client of mine had some dashboards that they were using for reporting, and the data for the dashboard come from views. And these views were extremely slow, and as a result, they figured that they could move the data from the view into an in-memory OLTP table. And because the in-memory OLTP table resides in the RAM and doesn't have locking blocking issues as such, they expected that it should be faster than just querying the view itself. And while that technically makes sense, it might not be the best solution for the scenario that they're trying to handle here. The first reason obviously being because in-memory OLTP is meant for OLTP workloads, and as such is optimized for those kind of scenarios, basically atomic inserts, deletes, etc. And the second thing being that when you're doing reporting and you have dashboards, primarily the queries are select statements. And select basically means shared locks, which don't really have locking blocking issues to the extent that we typically encounter with write versus read kind of locking blocking situations. So I wanted to kind of show a demonstration of this and explain why in-memory might not be the best solution as compared to maybe having a column store index on the table, and that's what this video is about. So the first thing I want to do is I've already gone ahead and created two tables here. The first one is a column store, actually it's an in-memory table here, this one, and we've created some indexes on it on the columns that we'll be querying. And the second one is a regular table which just has a clustered column store index on it. And then we have a regular store procedure which queries the column store table, and then we got a natively compiled procedure which queries the in-memory table. And inside of these procedures you can see that we've got two select statements which query on the month, and the other one queries on month as well as the arrival delay minutes, for which we have the appropriate indexes. So I wanted to go ahead and just quickly show a demonstration of this, which I hope will kind of clarify why a column store index would be a better solution here. So the first thing I'm going to do is I'm just going to run set statistics time on so that we can capture the time. And what we'll do is we'll run the query for the dashboard. So you can see here this one is again the exact same query, but it's querying from the clustered column store index table, whereas this is the in-memory table and it's using a natively compiled store procedure, and the rest of the stuff remains the same. So I'll just go ahead and run this, and you can see that when I run it, the first query takes about 150 milliseconds, the second one takes 94, and we have a total execution time of 264 milliseconds. So I'll just run this a few times just so that we get something like an average. So we got like 213, and we'll just do it one more time. So we got 138. You'll see that here we got 0 because I put a random function there so that it fetches different result sets, and that way we get something similar to how a user would query it with different filter criteria basically. And you can see that on average we're looking somewhere at the range of 250 milliseconds when we're using the column store index table, and yeah, 230 milliseconds for the column store index table. And now we'll do the same thing for the in-memory table, and as you can see again for the in-memory table, when we run it, you got 665 milliseconds. So I'll just run it again and get an average. So you can see 719 milliseconds. Just again 864, once more 795, and again 765. So you can see that on average the in-memory OLTP table for the exact same logic essentially takes about 760 milliseconds as compared to the in-memory as compared to the clustered column store index table, which was taking about 247 milliseconds. And both these tables have close to about 5 million rows in it, 5.8 million rows actually. So you can see that we've got something that looks very similar to a data warehousing kind of concept, and that's basically what I wanted to show you, that for a data warehousing workload you're obviously in a better state if you use a column store index compared to trying to put that data into the RAM and then have everybody query off the RAM. The reason being that the column store index also stores all the data in the RAM using the large binary object format, and it's also compressed using the Vertipack compression logic, so the memory footprint of that table in the RAM is also significantly less. In addition to that, obviously data warehousing queries require a lot of parallelism considering the amount of data that they fetch, and those things are usually better aligned with the column store architecture than the in-memory OLTP architecture. And that's why in-memory OLTP might not be the best solution to scale out read queries. It'll obviously be a better solution for DML operations like insert, update, and deletes, but not so much for select statements. Now, having said that, there is a feature in SQL 2016 called in-memory OLTP analytics, or basically operational analytics for in-memory OLTP, which allows us to go ahead and create column store indexes on the underlying in-memory OLTP table as well. And this way, we would be able to use an in-memory table for both OLTP transactions as well as data warehousing queries. And that will be the demonstration that I'll show in the next video, where we'll go ahead and load the exact same data into that type of table and try to go ahead and do some queries off that. There are obviously some limitations in implementing that feature as well, which we'll discuss in that video. I hope this kind of clarifies when to use and when not to use in-memory OLTP as compared to using column store clustered column store indexes in different workload scenarios. I hope this video kind of clarifies that, and I hope you enjoyed this video, and thank you for watching.